Hello and welcome to our LT Spy Secret Simulation series. My name is Castillo from ECEA101 Lab Section B2. And today we're going to create, analyze, and simulate a full-wave bridge rectifier in this video. So for every circuit, we will need a voltage source. So we have voltage source, and this time our voltage source will be inside A, meaning this will have a AC voltage input, and for amplitude we will have 10 volts and a frequency of 100. And for a for a bridge type rectifier, we need four diodes. And we will use the 1N418, and it is connected in this manner. And we will need a resistor though here. And for this simulation, we will use 1 kilo ohm, and we need a ground, and of course we need to connect them with wires. So it is connected in this manner. Oops. So this side is connected to the ground, and that the name bridge type rectifier is because it looks like a bridge when connecting a load. So it is connected like this. And then in order to simulate, we have our stop time at 66 milliseconds. And now oh, of course, for better representation, we will need a label. V out. So we will have V out 1 here, and V out 2 on below. And then we sample it again. So we click on the voltage in. As you can see, the 10 volts amplitude gives us a 20 volts peak to peak, an alternating uh, flow of voltage with 20 volts peak to peak. And to measure our output, we measure it across the load, which is our R1. So as you can see, from alternating flow of voltage, we now have a voltage output of pulsating of pulses on the positive side of the graph. So if we analyze our circuit during the positive half cycle, during the positive half cycle, the voltage flow from the positive side of the source goes up and goes here. And when it goes here, diode 1 is in forward bias, and that's the only diode that is in forward bias, so it will flow to diode 1. And diode 2 is in reverse, so it cannot go to diode 2, and it will just go to the top side of our resistor R1 and goes downward, goes back here. And voltage flows from one side of the input to the other side of the input. So this means that both the voltage flow will go to diode 4. And because if it flows to diode 4, it will complete the cycle because it will go back to the source itself on the other side of the terminal of the source. So to reiterate, during the positive half cycle, the voltage flow from the positive side of the input terminal, goes to diode 1, flows to our resistor R1, and it goes to diode 4. And after it goes to diode 4, it will go back to our negative side of the source. So if we analyze during the negative half cycle, the voltage flow from the negative side of the input terminal goes down, goes up, and diode 2 now is in forward bias. So it will flow to diode 2, because dial 4 is in reverse, go to dial 2, goes up, and flows to R1. So if you can remember, our voltage flow during the positive half cycle goes also to the top side of the R1. It is the same as the flow from the negative cycle, which is also to the top side of R1. And that explains the uh, pulsating voltage output on the positive cycle, because both cycles flows on one side of the resistor load. So after it flows to R1, goes down, it goes right here again. So if you can remember, it cannot go to diode 4 because if it flows to diode 4, this is the side of the input terminal where it came from. So that's not possible. So it will go to diode 3. After it goes to diode 3, it will return to the source, which is the positive side of the input terminal. So to reiterate, during the negative half cycle, the voltage flows from the negative side of the input terminal, goes down, goes up, flows to diode 2, goes up again, and it will flows on the same path, on the same side as it flows in the positive half cycle to the top side of R1, and it will flows right here again. And in order to complete the cycle, the voltage flow will go to diode 3 and goes back to the positive side of the input terminal. So if you we if we keep track of the diodes that each uh, cycle passed through, we can remember that both cycles passed exactly two diodes each. So if we can remember that a voltage drop of diode is 0.7, and since we passed through two diodes, so that's a total of 1.4 voltage drop. So that will explain the discrepancy of our voltage input of 10 volts. So as you can see, that's roughly 10 volts, and our output that has 8.6. So as you can see here, 8.6. So this is just 10 volts input minus the voltage drop, which is 1.4. And we can remember that both cycles pass through two diodes each exactly. So that explains the voltage peak of our output at 8.6 during both cycles of the input. So yeah, so 8.6 during the positive half cycle of input, and 8.6 as well during the negative half cycle of the input. So that completes our analysis simulation of full-wave bridge rectifier. I'm Carl Castillo from ECEA101 Lab, Section B2, and thank you for watching.